Hey guys, I want to go over two examples with you during this video. One dealing with infinitely many solutions for systems of equations in three variables, and the other dealing with no solution in systems of equations in three variables. So our first example deals with infinitely many solutions. So I'm given three equations, and remember our steps. I'm going to pick two of these equations to eliminate a variable from using the remaining equation. And what I've done is I've gone through and I've color coded them. So equation 1 is in red, equation 2 is in blue, and equation 3 is in green. And what I've chosen to do is eliminate z from equations 2 and 3. And I'm going to use equation 1 to do that. This is the remaining equation. So in order to be able to eliminate z from equation 2, so here's equation 2 and I'm looking at eliminating z, I'm going to multiply equation 1 by a negative 1. That'll give me a negative z. And then I add them together to create equation 4. And then to eliminate z from equation 3, I'm going to multiply by a negative 3 to equation 1. Negative 3 times equation 1, so I multiply negative 3 through everything in order to make my z's opposite. I add my two equations together to create equation 5. Next, I deal with equations 4 and 5, and what I've chosen to do is to eliminate y from equation 4 and equation 5. Well, what I end up with is 0 equals 0, a true statement. I'll go ahead and remove this. The equations are dependent, infinitely many solutions. Now you can still solve for the coordinates x, y, and z, meaning that x, y, and z, there's a relationship between all three. So this is where your infinitely many solutions take on a different form. Using equation 4 or equation 5, solve for x or y, whichever one. What I did is I chose to use equation 5 and I solved for x. I'm now calling that equation 6. I now plug in the value of x for equation 6 into the remaining equation, equation 1, and I solve for z. And this is my solution here. See, I have y in my equation for x. I have y in my equation for z. Y will just be y written as a coordinate. But x will not be just written as the value x. It'll be written in terms of y. X will be written as 3/2 y minus 2. And z will be written as a negative 5/2 y plus 9. Meaning that whatever I choose to be my y value, 0, 1, negative 4, I can then find the subsequent x and the subsequent z values based off of that y value. And this is x, this is y, this is z. And with this, if I chose differently, if I chose to eliminate the x variable and went through, I would end up having a different set of coordinates based on whichever one. I could have this be x, and then my value of y be based off of x, and my value of z based off of x. This is not the only answer. I could have three different answers, but no matter what, one of my variables inside of my solution is simply going to be that variable, x, y, or z. In the example that I did, it just so happened that it was y. And then my other two variables are based off of the given value of y. This is solving system of equations in three variables and ending up with infinitely many solutions. Let's look at no solutions. No solutions is easier than infinitely many. So these are my equations I'm given, color coded. First thing to do is to decide which variable am I going to eliminate, and I need to emphasize what I've chosen to do is arbitrary. You may choose to do a different variable. I chose to eliminate x, and I chose to eliminate it from equation 2 and equation 1. So in order to make equation 1, or equation 2 and equation 3, in order to make equation 1 to where I can actually cancel out the x from equation 2, I multiplied by -2, creating opposites, giving me equation 4. And in order to be able to cancel out x in equation 3, I multiplied equation 1 by -8, giving me opposites, and creating equation 5. I chose to eliminate y from equation 4 and equation 5. I could have chose to eliminate z. It's irrelevant. But in doing so, I end up with an untrue statement. Inconsistent, independent, no solution. Untrue statement. That is a look at two separate examples, one dealing with infinitely many solutions and one dealing with no solutions for systems of equations in 3 variables. I ask that you watch the publisher's videos, that you critically think and structure your homework, and good luck on your homework.